were airborne for just a moment, and we were really up in the air. We were really up in the air.
Hello, and welcome to another video with Maxwell's Virtual Aviation. As you can no doubt see, we are on the flight deck of the Hughes Hercules, and we just took off from Long Beach, SB01, if you've got that really awesome seaplane airport mod that I mentioned in my last video, heading roughly towards San Francisco. But there's something different about this, and I want to talk about it, and as well as some of the stuff that I've picked up since my last video. So today we are going to go over this Autopilot mod that just dropped for the aircraft, and a little bit about the fuel systems and associated other systems of the Hercules. So, Autopilot mod just dropped on flightsim.to. I will of course have a link to it in the description. But let me say that this is what I have been waiting for a very long time. Because now, flights like this become much more possible. I am not flying the aircraft for 4.5, 5, 6, 7 hours. I have an autopilot. If I can pick an idea of where I'm going, we can get there. So let's hop outside real quick, and I will show you, one, what the data shows, and how cool it is. So here we are. We're at a really good cruise speed. And I want you to notice a few things. I've got the autopilot obviously engaged. I'm not flying the aircraft. The reason this full HUD is important is it shows me what my autopilot is doing. Let's look at our compass rose up here. That little blue notch tells me what my heading is because I don't have the instruments in the aircraft to show me what it is, right? And I can adjust that. Down here, my altitude shows me what my altitude is set at. Currently it's set to 10,000 feet. That is what my altitude setting is. And also, if I need to, my vertical speed indicator, which I normally just use the gauge in the cockpit to get that set. But pretty much, that's all you need. And that is really all you need. So we are on our way to San Francisco, and I can sit here and record this video, and we can look at some other stuff without having to fly the aircraft. My co-pilot's taking care of the radio. Oh yeah, another mod that I'm running is this rather attractive navy paint scheme. It's kind of nice to not be flying in the prototype scheme, but this is just a test by the Naval Air Transport Service, let's say, to test out the Hughes flying boat in some sort of alternate reality where instead of the Martin Mars, they went with the superior aircraft. Now, it should be noted, a couple of things, is that one, had this actually happened, this aircraft would have been probably built out of metal. Before the right after the contract was actually finished, the War Department came to Hughes and said, if you'd like to do this in metal, you can do this in metal. He did not. He had already expended a tremendous amount of energy in the wooden structure of the prototype, and he believed that it was possible that it was stronger and possibly lighter than metal. Howard Hughes in his Flying Boat by Charles Barton touches on that and covers it in a little bit of depth. I think it's a must for any person who's a Hercules fan. But this probably wouldn't have been metal. It would not have been made out of birch. But isn't that cool looking? After San Francisco, it'll be off to the Pacific. Give the enemy what for. So, I'll throw a link to this particular livery down in the description as well. There are a couple other liveries that are coming out. I know there are some even more amazing liveries coming out. So keep your eyes peeled. We're gonna have fleets of flying boats all over the world. And the cool thing is with an autopilot, just a simple autopilot that will hold altitude and heading, we can go anywhere we want. All right, let's hop inside real quick. So welcome, of course, to the flight deck again. Let's turn on our overhead light here. There we go. So let's talk about the dials. I'm going to get rid of my control column here. So let's talk about these dials. So everything that I'm about to talk about, for the most part, deals directly with a post-flight Hercules. All right, this is the manual that I have, the Spruce Goose Hughes HK1 parentheses H4 parentheses flying butt manual by Periscope Film LLC, originally published by the War Department and Hughes Tool Company. This manual is post-flight, and a lot of the things it talks about were after the flight. And remember, this this flight deck we have is flight deck. So 2nd of November 1947. This manual was printed after that. Let's talk about these dials, right? Let us assume that what is in the manual was what was in this, right? So we can go to the section that deals with all of the instruments, and something very interesting here, which is that pointers, numerals, and main graduations on instrument dials are yellow fluorescent coated and become illuminated under fluorescent lighting. That's 1-8.1. So there was a method in which these would glow, but it doesn't appear that there was actual instrument lighting as we know it today. Was it added later? Possibly. Again, this aircraft was improved up until Hughes's death. Engines run every week until they came up with a system that would turn the engines automatically. And all of this worked. So that's what's so amazing about it. But again, looking at a flight deck. So that would be kind of cool. What's interesting is if we look down here, see the autopilot with pitch up and down. And then this is radio phones and stuff. I talked about the trim tabs in another video, which are here. So let's wander over to the flight engineer station and discuss the fuel systems of the Hughes Hercules. Tell me that it doesn't look absolutely awesome to look out and see all those props spinning, because I think it looks absolutely awesome. All right, let's see here. All right, we need to go right over here. Using my Xbox controller here to move my camera around. All right, so let's take a look at this panel right here. This is not, as I mentioned in the previous video, the flight engineers panel that you see today in McMinnville, Oregon. This panel was pure prototype panel. We need to get something in there, and well, it worked. So it's good though, because it really does show how the fuel system of the aircraft worked. And we'll jump up to the cockpit and I'll show you the fuel diagram they have that also show how it works. But basically, what you see here, these are your wings, these are your engines, and then these are your hull tanks. So you have two main wing tanks, left and right. These switches here are your firewall fuel switches. Normal, closed, and emergency. They're in normal, they can't move. I mentioned that in the last video. There's a booster between the tanks and these, and then these split off and feed, the boosters feed two engines each. Here, 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 and here. So that is how that works. The primary fuel is held in wing tanks. There are 15 things, but that's not quite true, and I'll get into that here in just a moment. But there are primary wing tanks. I believe wing tanks hold 900 gallons apiece. And what's really cool is this system had single point fueling. If you know anything about aircraft, having a single point for fueling makes filling up an aircraft much easier. And in 1943, when they started building this anyway, or designing this, it had a single point fueling system. So the fuel tanks It's interesting. So in the manual, they mentioned a few things that I'm gonna discuss, which I am not sure if it was the same on flight day or not. I don't have that information. But there are 8 hull tanks installed at the time that this manual was written. So this is post-flight. There were 8 hull tanks. There were provisions to hold up to 14 hull tanks, which I think is what we're looking at here. Yeah. So this is full hull tanks here. A couple of different things about the different tanks. Tanks 5 and 6 are standbys being connected to the regular fuel system, but it is to be used only in an emergency. That's 1-5.2 under fuel tanks. In the case of a leak or one of the filled tanks. The normal fuel capacity of each hull tank is 900 US gallons. The 2 wing tanks, with a normal capacity of 300 US gallons, are provided 1 tank in the leading edge of each wing forward of engines numbers 4 and number 3. And then hull tank number 8 contains reserve fuel and under all operating conditions should be used last, as it is connected directly to the emergency fuel system. So there are multiple fuel systems. Redundancy was a huge part of the Hercules, and it really pioneered this idea that modern airliners have today, right? You've got multiple ways of getting fuel. Now, what's super interesting is how fuel is transferred. So the fuel started in the hull tanks, was then brought up to the wing tanks, and then from the wing tanks, it was sent out to the engines. So engine-mounted pumps are normally what supplies the engine. The hull tanks under normal system operation, this is 1.1-5.2 or 0.3. So under normal system operation, each transfer pump delivers the fuel from the hull tank manifold to its wing tank. And then each wing tank then supplies fuel through a manifold to 4 engines, 2 on each wing. And then the 2 manifolds have a manually operated crossfeed located at the front. Okay. So all of your fuel is in your hull, sent up to your wing, and then out from there. What's really interesting is that gravity was used to move the fuel around. By proper use of shutoff valves, part of the fuel can be transferred by gravity from one tank to another. So that's really cool. You don't necessarily need mechanical means in order to do that. And then the fuel booster pumps I mentioned earlier. Fuel booster pumps are here. They're not normally used in cruise because the engine-driven pumps are normally enough. And then it kind of goes into the bypass and stuff like that. So we're looking at a very complex, but also a really cool way of moving fuel around. Now, I am not sure how fuel was handled on the day of the flight. There's just not a lot of information that I've found so far about that. There was an entire emergency fuel system. And if you look at how things changed post-flight, and you look at the fuel system control panel, I will throw a picture up here. It changes. These levers become switches. And this panel, instead of being deep, simply it becomes flat. A much more almost compact panel. But all of these are still here. Something interesting, right? Let's go look at this panel here. Our electrical panel here. So do you see these oil dilution switches right here? So these engine primer switches are functional in such as they move. And of course the engine starters are functional in that they start the engines. These oil dilution panels or switches don't work. And that is actually exactly as it was. If we look at moving over to 1-8.6 Flight Engineer's Instruments, subsection A, Flight Engineer Engine Panel. Number 3, 8 oil dilution switches inoperative. So those were never, at the time that this was written, the oil dilution system didn't work. So, but yeah, I just think it's absolutely fascinating. And let's talk about engine oil. Holy cow, man. I'm kind of all over the map here. But each engine had its own engine lubrication system. And what it would do is it would circulate oil through the engines automatically. Eventually, there are all kinds of automatic systems that take care of a lot of the things that the engineer would have to do. There's an entire chapter in here on the oil system and how it works. I'm not going to get into a lot of depth because that's not really the point of this particular video. But the oil system pretty much automatically ensures that the engines have proper lubricating oil. And that is what this panel here controls and what you see here. It would be kind of cool if we could open our oil valve simply to, because that's what you would do. You'd open your oil valves so that you'd get oil to your engines. And that would just be kind of a cool thing, I think. So. But yeah, there's a lot more I could talk about, but a lot of it simply isn't in this set of instruments. If we, like the feather switches here, you can feather and unfeather the propellers in this aircraft. It's not modeled, unfortunately. It'd be cool if you could press this and turn them off, and the propellers would feather in flight. That would actually be really cool. And then you have engine synchronicity. You could synchronize the engines automatically, and there was an entire system that did that. And what's really interesting also is things like the autopilot and everything. These 115 volt and 26 volt inverters ran different systems. So you've got multiple different electrical systems running multiple things on multiple different voltages, both AC and DC. A very, very, you've got DC here. And then you have inverters to supply the AC power. But things like the autopilot were controlled by the AC voltage as opposed to the direct voltage that was used for things like the starters and whatnot. Again, very, very fascinating, and it's really cool that we can go back and look at this. Let's hop back into the pilot seat here. So as I mentioned earlier, this panel changes right here. I'll throw up an image from the manual of what this panel ends up looking like. Sorry for the grainy images. It is as I got it. But there are all kinds of systems that simply aren't here yet. There are about 12.5 steps in the startup sequence to move hydraulic levers and things to set the engine, set the aircraft up to go. We don't have those yet here, obviously. This is primarily, it looks like radio and the interphones. There are like 36 interphones, inter-aircraft communication devices scattered throughout the airplane. That's how you talk to people, which is really cool. And then over here we have, let's take a look at these. Let me get my camera here. By the way, I've unlocked my graphics card, and this is looking better than it ever has before. So obviously you have your 4 throttles. These are air-controlled throttles, and I'm gonna butcher this terribly. They were talking about the master throttles and how difficult it was to actually use them. I have no idea how to pronounce this. I'm gonna put the word here and how they were operated. So they were operated by these devices, and they were used for the only flight. They were replaced by electrically operated throttles, which is what you see today and what you see in the Aviator. They were all designed about air, and the problem was they would never reset to the same position. Basically, the problem was it was an air system that was closed, right? So it was kind of worked like hydraulics, but on air. So the force that you would apply on the throttles would then be transmitted elsewhere, and it would replicate that, right? Well, it never worked. It never worked. And they had a lot of problems with them. So these throttles over here, the master throttles, or I can never get this word right. I will put the other word, type of throttles, over here. They were set up in series. So when they first started using the throttles, he'd pull them back to idle and they wouldn't go to idle. And David Grant, a hydraulics engineer who acted as the co-pilot on the first flight, only flight, was telling them that the Vernier throttles are set in series and shouldn't be used unless he intends to leave the power set long enough to make it worthwhile to even things out. So he's getting really gross general movement in his throttles, and then the engineer has to go through and set them. And it was said that the engineers at the engine side, in the wings, could actually got really good at setting those engines from their stations, even more precisely than the throttles in the cockpit. And then we have hydraulic systems, the separate hydraulic systems. There are multiple hydraulic systems in this aircraft. These levers control them. This is the throttle transfer, which transfers control from these throttles back to the engineer, depending on what it is that you're doing. And then those are, of course, duplicated on this side. I am very curious if this lever here is, in fact, prop pitch. I'm not sure, but it's interesting. So this is a momentary throttle for your prop pitch, low and high. So you can control it that way. And the instrumentation here is pretty much as it was on the day. Again, this isn't the same instrument panel that we have today, but from the bottom we have the BMEP, we have revolutions, manifold pressure, your cowl flap indicators. Now, the cowl flaps are interesting. On this, they're switch activated down here, and you can actually open it and close it to get a specific setting. Eventually, there was a master cowl flap switch that would open all of them together and close all of them together. It would be nice to be given a little bit more control of that, because cowl flaps actually weren't open 100% on taxi. They were only open 25%. It would be really cool to be able to, you know, get that 25%. That would be appropriate as to what you would see. Cylinder temp, and then your fuel flow here. Coolant temp, your oil cooling flaps. Oil cooling flaps. There are switches here for your oil cooling flaps on this panel, and they are here. It says oil cooler flaps, and you'll see how I get my little arrow there in both directions. Doesn't seem to do anything. But here's the thing. The oil cooling flap system was automatic. It depended on the temperature of the oil on what the oil cooling flaps did. So while it's kind of cool that apparently being able to override the oil cooling flaps you could do, it was primarily an automatic system. So the fact that we're unable to do anything with it right now is fine. That's as it would have been. And then my oil temperature straight up and down, which is good. I don't know how the engines are modeled, right? I do know that only one engine is connected to your output, and that's engine, I believe, engine number 1 for my, so on my Bravo throttle quadrant, I have indicator lights, and I also, low oil and low fuel pressure are based off of engine number 1. So, and then of course your oil pressure and your pneumatic pumps. So, I don't know how the engines are modeled. I don't. I'd like to know a little bit more and just, you know, see if you can stress them, or if, you know, but over here we have our props, reverse and feather. There was a plan to have reverse on these engines, but after the F-11 flight, where he crashed because of a low oil, which caused the prop to reverse, he decided to remove the reverse functionality. I believe, in my opinion, that had this continued to be produced, then the reverse thrust would have been put in. It would have been absolutely essential in maneuvering as a cargo aircraft to have those. And then, of course, you have your inverters, number 1, number 2, and then your 115 inverters, all that operate different things on the boat. Here's something interesting. So on these lights, right here, there's a switch. It'd be really nice if we could activate those lights individually. Although, there were switches that would activate all of these lamps at once. Be nice to have individual switches on them, and then also those ones there. Looking back here, this orange thing is obviously a life raft. They were carried in various points on the flight deck. There's one of the fire extinguishers. You can find all of this in the manual where all of the life rafts were, where all of the fire extinguishers were. Absolutely fascinating. And then I noticed while I was wandering around with my Xbox controller that you can only go back so far, right? I think you stop right here. Right there, that door, that leads to the wing. That's the leading edge of the wing, and you could go back there and you could look at, you know, your engines and stuff like that. And then this panel and everything, there's a picture, and I will put it up here, of this back wall and Hughes there. Sorry for the poor quality, but, you know, these are scans from books that I have and whatnot. But, yeah. As I mentioned the last time, pretty much this is it on the day. And with this Autopilot mod, we can now do stuff like this because I don't have to sit here and fly the aircraft while we do so. So, thank you for joining me on another ramble through the Hercules and just some of the stuff that I'm continually learning. I think the biggest issue with trying to understand the aircraft is that the aircraft we have today is not the aircraft that was flown on the 2nd of November 1947. They are in some ways the same aircraft and in some ways radically different. It's a more finished aircraft. It's a more polished aircraft. I mentioned in my last video the bracing of the tail. That some say is a direct result. There's talk of metal stiffeners on the inside of the aircraft. Just various things that, exist in the aircraft that we know today. But all I can say is that Blue Mesh did an absolutely amazing job of recreating this aircraft. And I have nothing but the highest praise for getting it done, because we never thought in a million years we would see this. Oh, I mentioned that diagram. Let's hop up to the pilot seat real quick, and we can look down here at this diagram. And here you can see the fuel system, right? Here are your engines, and then here you see where your firewall switches are here. And then what's interesting is these are apparently wing tanks, but it's not 7 wing tanks an engine, it's 7 hull tanks. And it would be 7 hull tanks that would then go up here. So that's how that would work. These would actually be down here. But still, another cool. This clipboard, I love this clipboard. The big thing for me is it lets me turn my APUs on and APUs off. So, and I guess I can shut my side curtains too. So, but yeah, this has all been possible today because of that Autopilot mod. I can walk around while we're flying. I'm gonna turn that light off because it is really bright. I can walk around while we're flying. Let's pop outside and take a look at this gorgeous aircraft. And not have to worry about it. So I'm not sure if we're going to make San Francisco or not. That's a long way away. But, yeah.